types of motion. And we have two types of motion with us, that is uniform motion and non-uniform motion. Now what is uniform motion? Let us see the definition first. The definition says a body is said to be in uniform motion when it covers equal distances in equal intervals of time. Now if we see the example over here, we know that the hands of the clock, they cover equal distances in equal intervals of time. That means the hands of the clock are in uniform motion. Now if I ask you a question, is the clock in uniform motion? What would your answer be? The answer would be no, the clock is not in motion because the clock does not move. Only the hands of the clock are in motion. So hands of the clock are in uniform motion. Whereas non-uniform motion is nothing but a motion in which an object covers unequal distances in equal intervals of time, right? So even here we have equal intervals of time, even here we have equal intervals of time. But in uniform motion, it covers equal distances, but here we have unequal distances. Just remember this, right? Now let's see the second point. Second point says the distance time graph is a straight line, and here it says that the distance time graph is a curved line. This line can be of any shape but a straight line. Now, what is a distance time graph? We'll understand this when we understand the concept of graphical representation of motion, right? So when you understand what is graphical representation of motion, at that instant of time, you will understand as to why the graph of uniform motion is a straight line. Let's see the next point. The next point says acceleration is 0, and here there is acceleration. When we actually understand the concept of acceleration in a while, we'll understand why in uniform motion the acceleration is 0 and here there is acceleration. And the final point will conclude by writing the example. And here the example is a car moving on a straight road with constant velocity. Now if it is moving with constant velocity, we know that it will cover equal distances in equal intervals of time. And here we have an example of a ball which is actually dropped from the roof of a tall building, and we know it will cover unequal distances in equal intervals of time.